So now we're going to look at a couple of alternating series, and we're going to talk about the process that we need to go through in order for us to determine whether or not the series is going to either diverge or conditionally converge or absolutely converge. Okay. So the first thing that we're going to look at is a fairly straightforward example that looks like this. The number doesn't matter. I could put a 5, I could put 11 there. It doesn't make a difference. So don't used to always think of n equals 1 there. And we got this series here. So now if we think about this for a second, we can look at this and say, well, what's going on here? Well, it's definitely alternating, right? So we know that if we thought about the three requirements for an alternating series to conditionally converge, it's definitely meeting requirement 1 by this first part right here. So 1 is met. Well, is number 2 met? Well, number 2 means that each term, the next term is smaller than the next. Okay, so if I think about first one, I have 9/10. So if I go to 3, I'm going to have 9/10. And then I'm going to have 16/17. And then I'm going to 25/26. Huh. This one's 0.9, right? By the way, I need the plus, right? But this one's 0.9. This is definitely bigger than 0.9. This is way bigger than 0.9. It looks like it's getting bigger. Each term looks like it's getting larger, not smaller. That's a problem, right? That doesn't meet number 2. So number 2 is not met. So since one of the conditions isn't met, boom, you're done. You can stop. You know that this is not going to converge conditionally. And for the record, if it doesn't converge conditionally, it's got no shot at converging absolutely. So this series diverges. We can take it one step further as well, and we can look at the third condition. The third condition says that the limit as n is going to infinity. This actually is probably easier to see. So it doesn't meet condition number 3. So this example number 1 clearly diverges because it doesn't meet 2 or 3. All right, let's try something else. We'll go with a 2. We'll move for a 2. Okay. So we look at this, we could start checking. We see it's alternating, right? We see it's alternating. So we could say, let's start checking the conditions, okay? So condition number 1, is it alternating? Yes. This first thing tells us here that it's alternating. Condition number 2, is it getting smaller each term? Well, I don't know, but I can start writing out a few. It's going to be 1/3. Then it's going to be, is that going to be a 1/8? And then it looks like it's going to be a 1/15 and a 1/24. Okay, they're getting smaller every term, and that makes sense because the denominator is getting larger and nothing else is there to kind of offset it. Okay, I'm okay with that. It's getting smaller. Now, what about the last part? Well, this last part. So we have all three conditions are met. 1, we see that it is alternating. 2, we see that a sub n plus 1 is less than a sub n. In this case, for all n, right? It starts right away. And then 3, the limit as n approaches infinity of a sub n is 0. We have conditional convergence. Now, when you're asked for conditional convergence, usually you're also going to be asked, does it absolutely converge? And here's the trick. You're going to have to do this anyway, right? You're going to have to do this anyway. You're going to have to go into this whole process of then saying, well, does it absolutely converge now? And here's the joke. If it absolutely converges, then there's no need for you to check conditional convergence. So what I'm basically telling you is that we just kind of wasted our time. The first step when we're solving these problems should actually be to check for absolute convergence. If we have absolute convergence, there's no more work to do. Absolute convergence means yes, it's kind of better than conditional convergence. It's more encompassing. So the first step we should have done is we should have gone in here and said, hey, let's check out this. The absolute value of it. Does this converge? Well, the answer is yes, right? If you just say, we know this converges by the p-test. And we can just see that if we take the limit of this, we get 1. Therefore, both series converge together. Because that 1's a non-zero constant, right? So we have absolute convergence. And if you have absolute convergence, you don't need conditional convergence. It's kind of like, well, yeah, that's like someone walk up to you and say, hey, I have a square. And you say, well, are you a rectangle? Yeah, of course you're a rectangle, right? If you're a square, you're a rectangle. Well, if you're absolutely convergence, you're definitely conditionally converging, right? Conditionally convergence is like a lesser version of the absolute convergence. Just like a rectangle is a square is a subset of a rectangle. Not all rectangles are squares. All squares are rectangles. Well, not all conditionally convergent series absolutely converge, but all absolutely converging series conditionally converge. So 3. We've learned our lesson, right? We've learned our lesson now. We're not going to go directly to. We're not going to start with the conditional part. We're going to start with the check absolute, right? So let's check absolute first. Well, I don't know about you, but I think I've seen this problem before. In fact, if I go back to assignment, was it 2 or 1? Let me get up to my page. I have it around here somewhere. Assignment 2, 1A. There's that problem. Assignment 2, 1A. And we saw that assignment 2, 1A, this diverges. So that means the non-alternating version, the one where the terms are all positive, is diverging. And if the positive version diverges, it means the alternating does not converge absolutely. So what it means, again, folks, I want to be very, very crystal clear on this. It doesn't mean that it diverges. It just means that it doesn't converge absolutely. Now we actually have to go in and check for conditional convergence. So now we have to go back and do these 3 tests. Well, let's look at them. 1, it's alternating. Why? Because this is always positive, and this is alternating signs every time. So it's definitely an alternating series. 2, well, what about the ln of n over n? Is this getting smaller each term? Well, we kind of learned about the race to infinity, right? How n is getting larger faster than ln of n. So we could kind of start thinking about ln of 2 over 2 and then ln of 3 over 3. And we know that the numerator is getting larger at a slower pace than the denominator. So yeah, it actually is getting smaller each term because the ln of 2 is not growing as fast as the denominator. So therefore, yeah, it's getting smaller every term. Okay, it's getting smaller every term. Is it approaching 0? Well, the ln of n over n, I mean, if you want to prove it, we can prove it real quick, but it's a question of the race to infinity. You might say to yourself, well, yeah, it's just a race to infinity. The denominator is going faster. But if you don't see that, if you don't believe me, just use L'Hopital's rule. There we go. So sure enough, it meets all three requirements for conditional convergence. Therefore, this series, this initial problem that I gave you, conditionally converges. So now when you're doing the homework, you're going to be homework, classwork, whatever you want to call it. Everything's kind of homework nowadays, right? So when you're doing assignment 3, what I want you to do is problems 1 and 2, as I mentioned in the assignment sheet, the agenda. The key thing is that when you're doing number 1, you're really just looking at whether it converges absolutely or not. You could actually figure out whether it conditionally converges or diverges. So go ahead and feel free if you want to do that. But the answer key, you're going to say, why does it say does not converge absolutely? Well, the reality is the problem 1 is just basically asking you to think about absolute convergence or not. And then problem 2 is when you start delineating all 3 of the possibilities. Please note that number 1 is basically trying to train you to think absolute convergence, because that's what you should be doing first. Does it converge absolutely? And then if it doesn't converge absolutely, then your next step is to figure out, could it be conditionally converging or not? Okay, so step 1, think about the absolute value. Step 2, go through the process of thinking about, now that it's alternating, or if it is alternating, do I have a situation where it's conditionally convergent? Okay, so I'll have those solutions posted soon to assignment 3. So enjoy your time exploring them, and I'll talk to you on the flip side.